Radiative forcing. A climate forcing is defined as the difference of insolation absorbed by the Earth and energy radiated back to space. Typically, radiative forcing is quantified at the tropopause in units of watts per square meter of the Earth's surface. A positive forcing warms the system, while negative forcing cools it. Causes of radiative forcing include changes in insolation and the concentrations of radiatively active gases, commonly known as greenhouse gases and aerosols. Radiation balance. Almost all of the energy that affects Earth's climate is received as radiant energy from the Sun. The planet and its atmosphere absorb and reflect some of the energy, while long-wave energy is radiated back into space. The balance between absorbed and radiated energy determines the average global temperature. Because the atmosphere absorbs some of the re-radiated long-wave energy, the planet is warmer than it would be in the absence of the atmosphere. See greenhouse effect. The radiation balance is altered by such factors as the intensity of solar energy, reflectivity of clouds or gases, absorption by various greenhouse gases of surfaces and heat emission by various materials. Any such alteration is a radiative forcing, and changes the balance. This happens continuously as sunlight hits the surface, clouds and aerosols form. The concentrations of atmospheric gases vary and seasons alter the ground cover. IPCC usage. The Intergovernmental Panel on Climate Change AR4 report defines radiative forcings as: radiative forcing is a measure of the influence a factor has in altering the balance of incoming and outgoing energy in the Earth atmosphere system, and is an index of the importance of the factor as a potential climate change mechanism. In this report, radiative forcing values are for changes relative to pre-industrial conditions defined at 1750 and are expressed in watts per square meter. In simple terms, radiative forcing is the rate of energy change per unit area of the globe as measured at the top of the atmosphere. Quote, in the context of climate change, the term forcing is restricted to changes in the radiation balance of the surface troposphere system imposed by external factors, with no changes in stratospheric dynamics, no surface and tropospheric feedbacks in operation, and no dynamically induced changes in the amount and distribution of atmospheric water. Related measures. Radiative forcing is a useful way to compare different causes of perturbations in a climate system. Other possible tools can be constructed for the same purpose. For example, Shine et al. Say, recent experiments indicate that for changes in absorbing aerosols and ozone, the predictive ability of radiative forcing is much worse. We propose an alternative: the adjusted troposphere and stratosphere forcing. We present GCM calculations showing that it is a significantly more reliable predictor of this GCM's surface temperature change than radiative forcing. It is a candidate to supplement radiative forcing as a metric for comparing different mechanisms. In this quote, GCM stands for Global Circulation Model, and the word predictive does not refer to the ability of GCMs to forecast climate change. Instead, it refers to the ability of the alternative tool proposed by the authors to help explain the system response. History. The table below shows changes in radiative forcing between 1979 and 2013. The table includes the contribution to radiative forcing from carbon dioxide, methane, CH4, nitrous oxide, N2O, chlorofluorocarbons 12 and 11, and 15 other minor, long-lived, halogenated gases. The table includes the contribution to radiative forcing of long-lived greenhouse gases. It does not include other forcings, such as aerosols and changes in solar activity. The table shows that CO2 dominates the total forcing, with methane and chlorofluorocarbons becoming relatively smaller contributors to the total forcing over time. The 5 major greenhouse gases account for about 96% of the direct radiative forcing by a long-lived greenhouse gas increase since 1750. The remaining 4% is contributed by the 15 minor halogenated gases. The table also includes an annual greenhouse gas index, which is defined as the ratio of the total direct radiative forcing due to long-lived greenhouse gases for any year for which adequate global measurements exist to that which was present in 1990. 1990 was chosen because it is the baseline year for the Kyoto Protocol. This index is a measure of the inter-annual changes in conditions that affect carbon dioxide emission and uptake, methane and nitrous oxide sources and sinks, the decline in the atmospheric abundance of ozone-depleting chemicals related to the Montreal Protocol, and the increase in the substitutes and hydrofluorocarbons. Most of this increase is related to CO2. For 2013, the AGGI was 1.34. The increase in CO2 forcing alone since 1990 was about 46%. The decline in CFCs considerably tempered the increase in net radiative forcing.